Um, Hi class, so I'll be doing project number 3, talking about logic gates. So for today's project, I'll be using these components. First, we will be using the jumping wires, the battery 9 volts, the Arduino Uno R3 controller, the breadboard, the LED, the diode, the resistors, and these two new ones that are the integrated circuit, which has inside the different logic gates, and then the transistors. For this project, we will be using the diode, which is a semiconductor device which allows current to flow easily to one direction, but it restricts the current to flow the opposite direction. This is a symbol for diode. The other component that we'll be using are the transistors, which is this one that have 3 pins underneath. So the transistors are semiconductor devices, meaning that it can conduct electricity under some conditions, but not others. For the transistors, we have 2 types: the BJT, which is standing for bipolar junction transistor, and has 2 other versions, which is the negative, positive, negative, and the positive, negative, positive, and then the field effect transistor, and has the metal oxidized semiconductor field effect transistor, which stands for MOSFET. The main difference between the BJT and the FET is that BJT uses both electrons and holes as charge carriers, while the FET, an unipolar transmitter, only uses one kind of charge carrier. We'll be focusing in the bipolar junction transistor, and so this transistor is conformed with semiconductor type N and semiconductor type P. This one having extra electrons, and this one having missing electrons, and the combination of these two give us the 2 types of this one, which are the NPN and the PNP. So here I demonstrate, I have 2 types of symbols for NPN and PNP. Here we can visualize that both of them have the emitter, the base, and the collector. The only difference between these 2 is the arrow direction. For the NPN, it's sync ground to the output, while the PNP has a positive source to the output. So the integrated circuits include logic gates inside. So the logic gates are devices that can conduct electricity. There are 7 different types, but for this project we'll be focusing in the main 3, which are the AND, OR, and NOT. For the symbol for AND, it looks like a D with 2 inputs and then an output, and then for OR has 3 curves, and then for NOT it has a triangle and then a circle, has 1 input and then 1 output. So for the logic truth table, to understand the function of these ones, we'll be using the logic truth table. So we will be using binary coding, meaning the 0 false or off, 1 on and true. For the AND, it will be multiplying. So for example, for 0 times 0 give us 0, 0 times 1 give us 0, 1 times 0 give us 0, and 1 times 1 give us 1. So this meaning that having a true output when both inputs are true, and then so if we have an output of 0, it will be meaning that we will automatically have a output of 0. And then for example in OR we'll be having here we'll have an addition, we'll add. So if we have 0 and 0, 0 plus 0 give us 0. False plus true will give us true. True plus false give us true, and then true plus true give us true. So the output will always be true if one or more outputs are true. And then, for example, in the NOT, the output is on when the input is off, and vice versa. Here we can show the 0 and 1, and then 1 and 0. So here we can visualize the circuit and then the AND gate on breadboard. Here the transistors are in series, and also here where the collector is here, the base pin is here, then the meter is connected to the other collector's transistors pin, and then the base, and then the emitter pin is connected to the LED. Here we can visualize if we unplug a jumping wire, the LED will automatically turn off. Showing here in the logic truth table, where if it is off times off, it will be off, and then if it is true times true, it will be true. So that meaning when both switches are on, the light will be on. So here we have the circuit diagram. Here we have the OR gate in a breadboard. So here this says that when one switch is on, the light will be on. When both switches are on, the light will be on. And when both of the switches are off, the light will be off, as showing here. 0 plus 0 equals 0, 0 plus 1 equals 1, etc. Here, while we disconnect a jumping wire, we can see that the LED does not turns off. And then when we disconnect both wires, the LED will turn off. So here we have our NOT gate on the breadboard. We have the circuit diagram, the logic truth table, and here we have our transistor, and in this way it is plugged in the collector, the base, and then the emitter.